second cloud service that we are using is the SQL Server data services. So all of the storage of the application that you saw is not going to SQL Server in this example that I showed. We have it as well, but the ones that I showed is using this storage on the cloud that Microsoft has made available and was announced like 2 weeks ago. So we have these two implementations, the multi-tenant based on SQL on-premise and the other one. And the other one is kind of interesting because the programming model changes a little bit. As I said at the beginning of my session, there's no tables, there's no indexes, there's no relations, there's no joins, there's no grouping, there's no advanced querying, there's nothing. It's a fake. No, it's true. There is a storage there, and actually it has very interesting features for our needs. What I want to say by this is that by no means I mean that you should forget about SQL Server. Obviously not. This guy over there, the SQL Server data service, is not for everything. There's no silver bullet. You guys know that. So it's just another offering that might be interesting and that might be applicable for the solutions that you're thinking of. And I will share with you some examples of people that are using it with a lot of success. So let me just jump a little bit on what is SQL Server Data Services. It's essentially this. But the interesting thing is that what are the benefits? There's a price you pay, all of the lack of artifacts, common artifacts that you were used to. But the benefits are that you don't need to worry about the storage itself anymore in terms of scale, space, disks, tuning, backups, recovery, failover, geographical distribution. All of that goes away. That's done by Microsoft. So if you need a data center with a virtually limitless storage, well, this gives you that. If you want a data center where the data is replicated across continents for efficiency, for lower latency, for legal issues, whatever, this gives you that. And hopefully with a very convenient price model. And Microsoft can do a very convenient price model because they are offering this to thousands of customers, not just for one of you. So if you wanted to build this on your own, it will be very costly. We can do it in a more scalable way. Now, what's very interesting is that they are also going to offer an SLA, a business SLA behind it, which is a unique characteristic, which I think is very important. I wouldn't, if I were a real ISV like Leadware, or like a Leadware-like, well, if they don't give me an SLA, I would never use it, or I would use it for non-critical things. An SLA means that some heads will roll if something fails. Somebody is accountable for that service. That means that I can get a credit, I can get a refund, I can get an apology letter from Bill Gates signed, or something I can use to explain to my own customers why my system was not available. So I think that's a very interesting thing. It's a very extremely, very, very simple model to use. Actually, it's quite really, really simple. And they have some model, which I'm going to show you, which is really, really simple to understand and very good in the space that Leadware is in, the multi-tenant, flexible, customizable environment that I described before. So in one slide, the model that SQL Data Services has is like this. There is a notion of an authority. An authority it's a container for containers. And a container contains entities. And entities are it's a bag of a collection of name-value pairs. That's it. So think roughly as the authority is kind of like a server. The container is like a disk, and in a disk, you store collections of entities. What's interesting is that entities have a collection of properties. Properties which have a type, which is good, it's not strings, But you can have, like, if you are positions, position dot name, position dot instrument, position dot whatever. But the good thing is that entities can have an unlimited number of properties, which is exactly what we need in LeadWare. There's no schema attached to any position, to any entity in SQL data services. And the container is just like a collection of entities, and there's a consistency. The consistency and the search scope is based on a container. All right? So in LeadWare, LeadWare has one authority for itself, has one container for itself to store its own information. All of the metadata of LeadWare is stored in LeadWare's container, and has multiple containers for each tenant that you create. So you see how naturally this model maps to what we needed in LeadWare HR. LeadWare has its own authority, it manages everything, and one container for each tenant, which gives tenant isolation, and then each position for each tenant in each container is different. And because I can have any property with each tenant, each entity, that's great for us. Okay, so let me show you now a little bit behind the scenes, okay? I think, yes. So let me just delete this. That's a REST query on the LeadWare's authority. So before everything happened, I created an authority for LeadWare, and I'm not sure if you see, is it too small, the letters on the URL? It says leadwarehr.data.sitka, which is a code name for this service. Don't worry about the name. .microsoft.com. So each authority that you create will create a DNS entry as well. All right, so if I am, say, Duwamish ERP, we have duwamish dot something else. And the query on the root is giving me the root container, which is an authority. So now if I want to see, and I think it was something like this. So what I'm querying there, that's a REST query for all the things in an authority. The only things that can be in an authority is a container. So what you see here, it's all the containers that are contained in this authority. Now, if I go to one in particular, which is the one that I care about, which is LeadWare HR, this is LeadWare's own container for its own information, its own data. So now if I query for all the entities in this container, what I see here are entities, flexible entities. And you see things like authorization, this is an authorization rule, this is an entity definition field. Let me go back down here, let's see. That's a workflow definition. So what you see there, it's a serialized XOML for a workflow definition. So these are, each of these, it's an entity in SQL database, in the data services, and it's an entity that it's managed by LeadWare HR. So now if I do a specific query for one specific type of entity, and the query language that SSDS uses, it's a variation of link. So it's a subset, it's not complete, it's not as powerful as link because it's tailored towards what SSDS can do. But I can write things like from in entities where entity kind equals tenant, select E. So what I'm saying is, bring me all the entities in your container which are of type tenant. So what I'm saying is, bring me all the tenants that you have here. There it is. So let's see. There it is. That's the one that we created before. Okay, that's Lisferenc Music School, And there's a name, there is an alias, there is the account for Silverlight. All of the properties that we capture in the provisioning form are here. More importantly, there is the ID of the tenant with links, everything together. So if you search for that ID in the container, you will see the menus, the style that I applied, the fields that I extended in the position. There is an instrument, experience. All of that will be tied to that particular tenant ID. And also, if I copy this and I replace here, that's Lisferenc Music School container. And if I go to, which was created at the time of the provisioning, and if I query for it, there is the position, a resume, and another position. Remember we had like 2 positions, the piano and the guitar, and my resume, which is the application. So it's a very straightforward, very simple model. And of course it's typed. So there is you see there is a date, there is strings, there's a Boolean, and here are the flags, by the way, which is interesting. You see, is video available? True. And is video uploaded? True. The second, the last one is the one that is set once the asynchronous service completes. This is the one set initially to flag that there is a video that has to be uploaded. Okay? Not all resumes will be the same. Not all positions will be the same because each customer, each tenant will be different. Any questions? Okay, good. So, I'm going to go fast on this one because it's a little detailed, and we can, a lot of this information will be published soon. But how does this work? We didn't, as leadword architect, playing the role of a leadword architect, I didn't want to have like a generic bag of properties, because it's like programming with a record set. It's going back to the dark ages of WinDNA. So I created this class, which is a repository of T's, and T is a type. So T can be a position, can be a resume. But also it's an extensible type. So I can have like a list of fields which are fixed and a list of fields which are flexible. But I did want the leadword developer to be able to do position.code, position.location, position sub-instrument, because instrument will not be in all positions. But that kind of experience. So the class repository of T's, it's like the only entry point towards SQL Server data services. Everything goes against that. All of the details of connecting, of credentials, of even mapping the tenant concept into artifacts in SQL Server data services like authorities or containers, all of those details are hidden underneath this abstraction layer. So below it, there's a proxy factory. There is the proxy itself. So this red box here is the one that is generated when you do add service reference in Visual Studio. That's the one that creates the client-side proxy classes for you to use. But there's a few interesting things that happen here. First of all, my development team is not in Redmond. It's outside Redmond. It's in a different country. We have people all over the world working with us. And also, we didn't have we were developing leadware at the same time that the SQL Server data services were being developed. As you can imagine, it was up and down, and for many weeks, it was very, very unreliable, simply because it was being developed. It is still being developed. But moreover, I wanted we are a TDD shop, so all of our development is done in a TDD fashion, meaning that first we develop the tests, and then we have a batch of tests, and then we write a code that satisfies those tests. And so we do a lot of, cycles around our unit tests. And because of the unreliability of the service, because it was being developed, because we did a lot of calls into Sitka, we created an offline experience for Sitka, but we did it underneath the proxy, and that's why we have a factory. So by policy, we can switch from one to the other. So I can develop, in the plane without being necessarily connected to the service. And I think that was a very good decision that we made. The other thing is that Sitka, in a way, violates a principle in application design that has been like, sacred until now, which is the data has to be close to the CPU where it's being processed. Well, it just happens that when you use Sitka, Sitka is in a data center very far away, potentially from where you are. So how do you minimize the impact of latency, and moreover, you will have to pay for each time that you call Sitka. So from a design perspective, it's good if we can apply some design considerations to minimize the amount of calls and the amount of information that is exchanged between these two tiers, between Leadware and SQL Server Data Services. And that's why we added this cache manager behind, that it's, again, driven by policy. And depending on the type of entity and depending on the type of data, we can be smart about what we return. So for example, a resume never changes. It's immutable in a system like Leadware. So resume, it's an entity that we can very aggressively cache because it will never change. You can apply to many times to a single position, but once you submit your resume cannot be changed anymore. That's a perfect candidate for very aggressive caching. And the cache manager is implemented with the caching application block, so you can use all of the nice features in, expiration policies and back in store, so we can cache in memory, you can cache in a local disk, in protected storage, whatever. But that guy over there allows us to minimize all the traffic when it's not needed. And the cache manager, we implemented also caches entity instances or caches complete queries. So if you say, give me all the resumes, and if you call it, you can tweak the window at which the things will be refreshed. But again, we wanted to surface the opportunity for making your app more efficient and also to save some dollars. There's two other things that we have to build. One is the cross-tenant search, because the container is the scoping element for a search. You cannot search across different containers. But we wanted to provide like a cross-tenant search, because as a recruiter, when I did, and I didn't show that, but when I search for a resume, I can search for applications that are being done to me, but also for others. And so how do we do that? So we implemented this thing, which is a cross-tenant search, that essentially what it does, and what's interesting of that from a technical perspective, is that it's a highly parallelizable task, because each container is different. So if you do a for each, as Leadware, if you do for each container in authority.containers search, you are in a bad situation, because you potentially can have thousands of containers. So what we did is we implemented a parallel search, where you essentially queue the request on, I can't remember now, it was like 100 or something like that, concurrent searches, and then we did a merge of the results at the end. So we're very efficient in searching in a large number of containers by doing a parallel search and doing the synchronization for that. And the last piece is what we call the unit of work. And the unit of work, it's precisely that. There's no transactions in SQL data services. You cannot do begin, insert, delete, update, commit. Why can't you do that? Well, because there's no API to do that. And it's very unlikely that they will do something like that. But nevertheless, I we needed some kind of consistency manager, something that we could treat multiple operations as being under one single logical operation. And that's what we implemented as a unit of work. From the acid properties, the only property that we don't quite have is the isolation, but we have kind of the rest, kind of. So you can do like begin, insert, insert, insert. We do have dirty reads. That means if we are doing that operation and somebody else comes and does a read on things that we are changing, they can get some information which is stale, basically. But we flag those entities so you know that it's stale. And SQL Server Data Services does implement optimistic concurrency protocol. Because I'm not sure if you saw that, but one of the properties that they have there, which is an intrinsic property, is the version. And version 2, why does it have a 2, by the way? Because it was updated when the video came back. So it means that if I do a read on the property with V1, I change something and I update it, and in the meantime somebody else change it for V3, SQL Data Services will raise an exception and say, hey, you change it while in the meantime somebody else changed it. So you do something. You could implement like the last one wins or on top of that, but it's up to you. That's another price and you need to pay, in doing that complexity on yourself. No. All right. So how much time do you have left? 3 hours? Excellent. 2 minutes? How much? Oh, great. Excellent. Okay, so just to give you a sense of what it looks like, let me see very quickly, so I don't get a lot of time with this here. I was planning to write the code myself on the demo, but we don't have much time, so I'm going to uncomment code that I already have there. So, copy this. All right, there we go. So essentially, if I'm a developer using these libraries that we developed in Litware, you would do something like this. You say, the class book is an entity, and it's an extensible entity. Therefore, we will have all the flexible properties that can be attached to that. And the iCacheable entity, it's the interface where you mark this class, this entity, to be cacheable. So if you have a cache enabled and your entity is iCacheable, then I can cache it. Otherwise, no. So for example, there might be some entities in your system that are not cacheable at all because they're not immutable or they're not very volatile. Okay? So if I write a test for this, just to give you a sense of what does it look like. Let me do something else. Insert, book, get, book, delete, book. Using this is something like this. Repository of book, repository, new, that's it. Book, book, new, book. Those are the fields. Notice that there are fixed fields, and then there is fields field, which is the extensible. That's a bag of fields. So ID, let's say GUI, new GUI, title. then I can do book dot fields. And this is an old API. This is wrong. So you shouldn't do this. It should be title, comma, the value of the title. But bear with me. I have to do this twice. I've been changing this a little bit. And now I do this. Repository insert book. And then I get a book. I get it, get the new instance, and everything is okay. Well, first of all, is not, no. That guy should be there. Second, the book, I don't know, say title. Oh, no. Variable x zeros. Okay, I don't care about that. There's tests. There's the fixture. Where's my test? So now, if I do, just to complete the test, repository delete, insert this, no. Very straightforward. Now, book is cacheable, so I can test for whether this is coming from the cache or not. So actually, in this test here, I'm inserting and I'm getting the book immediately afterwards. So if I do assert dot is true, this would probably fail. Should fail. Yeah, and it's not true. So why, if it is cacheable, is not cached? Well, because my repository is not caching. There's no caching enabled in the repository. So to do that, I would do things like that's just some boilerplate code that I need here. And then cache manager. I want caching, and I want an expiration, which is a slide time. Time span. There. So what I'm saying is I want to use a cache with a sliding time of 3 seconds. So things will be cached for 3 seconds. Afterwards, it will expire and it will be gone. So now hopefully between this and this, it will be before 3 seconds. So if I run it again, yes, and this is because, why? Of course, I was telling him, I need to tell them, the cache, that I want to cache entities, not queries but just entities. So cache, please, entities, and don't cache queries because we don't have any. Go again. Yes, there it is. So now, the entity is cacheable, the repository has a cache, now it's working. If I put here like, let's say, before here, no. Don't do this at home. So something like that. So this should be false. Okay, because now I'm waiting more. I'm retrieving the entity again after 3 seconds. Should be false. Please. There it is. Yeah, 3 seconds. Okay, so that's the flavor of the API that Leadware is using underneath. All of the flexibility, of using the experience of the developer on top of that, which is a fairly high level experience. It's not something which is completely alien to a developer. All right, so let me go back here and quickly. Here it is. So this implementation that I showed is using SQL data services and these libraries that I demoed right now. But there's another implementation which is using SQL Server, and we did implement an extensible mechanism on top of SQL Server. And there's usually 3 types of extensibility methods used. One is the fixed columns, C1, C2, C3, which SQL Server likes very much because it's square. Then there's people using XML data types for the extensibility fields. It's okay. There's some performance implications of that. And obviously there's a hybrid programming model that you have to deal with. You have a mixture of T-SQL and X queries. So it's your queries look like a little bit different. And then there's the third option very much used, which is using like an extension table for name value pairs. That's the one that we used because it's quite, there's the trivial way of implementing it is not very performant. So there's tricks that you have to do in SQL statements to do the last one in the right way. And for that, we have 2 things to offer you. One is a version of Leadware that does that, and a performance guide that with the tests and with the recommendations that compares the 3 options with different variables, like with concurrent users, with extension fields, with number of tenants, and with number of rows per tenant. So with all those variations, you can test one and the other. Okay, so that's 2 things that you can also take a look at. So now I'm going to use the last 15 minutes or so that I have left, maybe 15 minutes, good, to cover 2 other options, the 2 other things that we wanted to cover today. And one is the running aspect of software and services, and a little bit of the consumption. From all of the aspects, these are the 2 that we have the least things to share with you. We have a lot of ideas and we have a lot of content, but not as actionable in terms of reusable code or running examples as we had for the running bits. That's why I started with running. But the idea is that when you host, if you look at Leadware, there's a lot of things that Leadware does that Leadware would rather not do. All right? So there's a lot of features in Leadware that could potentially be pushed down into the hoster platform. And that's what we call the service delivery platform. Our observation is that most hosters are like this. What they offer is Windows hosting, meaning that the common denominator becomes the platform, becomes the operating system. And you guys know that two different Windows apps could be very, very different from each other. Okay, so just to give you one example that I always use is most applications have exception handling and logging, but no two applications have the same implementation of the same logging and the same exception handling. One application might choose to do exception handling on the Windows event log. Another one might choose to log exceptions into a database. And a third one will choose to log exceptions on a database with a different schema. Now, from a developer perspective, it's okay. You know, in all cases, you're doing exception handling, which is good for the app, at least to know when things are going wrong. But from a hoster perspective, what happens is that you are in this situation where operating efficiently two different apps means being archaeologists of one app and the other. You need to understand, open the app and say, oh, how do you do exceptions? Oh, I log in this database. So when there is a problem, I know where to look. Now, if I'm Northwind hosting and I have 10,000 applications, how do you think my life will be? Very miserable, because I have to go, 10,000 apps, all different. So our point with this is that in the same way that there is application exception logging, there is, data access and many other things, there's an opportunity for hosters to raise the level of abstraction on the services that they are offering. So they could tell you, if you do these things this way, I can give you all these services for free, so to say. For free? No, not for free. But if you follow these rules, then I can give you these services cheaper than the guy that doesn't follow the rules. They can still not follow the rules, but they will have to pay more. So that's the whole idea of this. And the other analogy that we always use is that, how many of you have your own file system? I always ask the same question. How many of you actually developed a file system, not in high school or in college, in university, in your own apps today? There's always somebody that has its own file system for the good reason. Mainly because, you're doing some embedded development or real-time development, and the file systems that the operating systems gives you is not enough. It's not fast enough. It's not specialized enough for that particular scenario. The truth is that most of us do not develop our own file systems anymore, because NTFS or any of the other operating systems, file systems are already good enough. So the same applies to other kind of services on the stack. There are some hosters that are offering, is there any hoster here? Okay, so they cannot say that I'm dreaming. There are some hosters that are offering these value-added services like billing, like metering, like self-provisioning, self-onboarding. I've spoken with one of the biggest hosters in the US, and the time it takes to host an app on their environment is typically no less than 2 weeks. Why? Well, because they have to understand what the application looks like. Can all of that be minimized? Could all of that be improved? And our assumption is that it is. It is improvable. And for that, we have something called the Northwind hosting demo, which is the final demo that I'm going to do, which is all fake. In the best, it's a best representation of Hollywood, here in Hungary today. Which is Northwind hosting. It's a demo. It's an end-to-end demo of what this hypothetical hoster would look like, offering these highly valuable services for ISVs, if ISVs follow those rules, if the application architecture is pre-known and defined in advance. So it's a complete walkthrough. It's quite quick, so I'm going to show you. But it's not meant to be guidance yet, because building this is fairly, it's a big project. So, but our goal with this was to raise the awareness of what could be done. And my prediction with a 0.7 probability, in the next couple of years, there will be offerings like this, especially coming from big platform players like Microsoft. Okay? So what I'm going to show you is the whole life cycle of a company like Leadware that wants to onboard its application, Leadware HR, on Northwind hosting. Okay? So the first step is understanding what the restrictions in the hosting platform is. And that's what Leadware does initially. So Northwind has a way of communicating what they can do for an ISV and what the rules are for them to follow. Then somebody in the team will take those rules and will change the app to make it compatible to those rules. Now, my point is, the point is that you cannot make those rules too restrictive, because if you make them too restrictive, then nobody will use the platform. Or then you cannot do anything with that system. So the third stage, it's taking the app, packaging the app, and sending the app to the hosting environment to be run there. And finally, onboarding and production. And I will walk you through all of these steps in a very quick demo. So, not this one. All right, so Northwind hosting. Oh, thank you. So again, I am TSing into 2 hops, actually. I'm doing 2 TS sessions, so it might be a little bit slow in refreshing all of the screens. But this is Northwind hosting. It's an S+S hoster, so they have all these traditional offerings like co-location and dedicated hosting, but they have one offering in particular, which is shared hosting. And shared hosting, they have SharePoint hosting, again, common thing, web hosting, and one which they call software and services hosting, which is meant for S+S applications built with Microsoft technologies like ASP.NET, WCF, Windows Workflow Foundation, and databases. By coincidence, almost exactly like Leadware HR. Believe me, it's just coincidence. So this is my app. It kind of falls into that category. If I bring an application which is different from that, I might not be able to exploit all the benefits. But let's see, they can offer me metering and billing, so I can bill my tenants they can bill my tenants on behalf of me. They can give me usage information, which is the traditional way software and services is used, which is you pay a subscription per use, per time, per seat, per transactions, things like that. And a few other things. They offer me advanced services, value-added services on top of the applications that are hosted there. They can do all of that if I follow this model, which is if my application is it's a collection of web clients, a collection of smart clients that interact with a collection of web services, that in turn interact with a collection of databases, it's fine. They can give me all of that. They can meter, they can bill, they can do management, they can do capacity planning, etc. Now, if I, for example, do a direct connection from a web page to the database, that's a violation of the rule. They cannot do that. They want to avoid doing that. They want to prevent people to do that. Why? Well, because their data center, it's tailored, it's optimized towards applications that follow this structure. This brings predictability and brings kind of a unknown, avoids all of the archaeology that the hoster has to do in understanding how the application it is. That's the goal. Okay, so kind of like that. So Northwind has packaged all of the rules, all of the documentation, all of the conditions for hosting apps of this type in the data center in what they call the development toolkit. And the toolkit is just a collection of assets, tools for verifying that I'm not violating any rule, for example. Imagine like a collection of FXCOP rules that I can run against my system to verify that I'm not in violation of any of the rules. But also imagine things like no hoster will give you say a billing system that I can use to verify that they're actually billing when I submit a resume. So what they will give me, it's a mock billing service that I can use while I'm developing, and then I can replace that at runtime, when I deploy this to the data center with a real billing system. But if I am developing, I want to be able to verify that billing is actually occurring, or metering is actually occurring. So this toolkit will have a collection of assets, tools, libraries, extensions, to Visual Studio, documentation on how I need to build an application that is compatible with Northwind capabilities. Let's say I do all of that. I go to my Northwind hosting. Obviously, I'm not a customer, so I'm going to register as a customer. And Eugenio. Notice the self-service experience, not just of the leadware tenant, but now it's hoster ISV. So the hoster allows me to self-provision my account in their own environment. I can capture billing information, who am I, contact information, etc. I go there, thank you, welcome, there you are. So if I go to my applications, it should be empty. That's the dashboard in Northwind of all of my apps. I don't have anything. I notice, by the way, that I have a staging environment and a production environment, which we will go there in a second. So now, while I was doing this, my development team is actually changing leadware to adjust a few things here and there, although leadware is highly compatible with this model. So now I'm going to use the package builder, which is one of the tools that Northwind gives me. And the package builder, it's a tool that collects all of the assets and the intent of those assets in a data center. So I can do things like this. This is Leadware HR. This is my first version. And my first app in Northwind hosting. Then I browse the solution. That's Leadware HR. And I have to communicate what is the role of those assets. Some of these will be web pages, some of these will be web services. And I cannot necessarily distinguish that from the projects themselves. So what I'm doing with the tool, it's mapping roles and responsibilities with assets. So I'm going to drag and drop, say, this is my web app. There. Oh, come on. And this is another one. That's not my intention. Okay. And this is my service. And by exploring all the web configs, we found that there's 4 databases that you use. How many times a hoster doesn't know, I need to send them the scripts, the backup, and well, this is discovered and it's made explicit at this time. So I can browse, I can say, these are the scripts for this particular database, so you can create it. Notice that leadware cannot define the connection strings in a web config because they don't know where the service will be hosted. at runtime. The names of the servers, all of those things are defined later on by the hoster. So all of this is capturing that. So my final stage is, as a developer, I build a package which contains all of the code, all of the assets, the GIFs, the HTMLs, the scripts for the database, and the intention of all of those, all of the metadata around it, the application, that describes it. I'm done. Thank you. I'm going back to Northwind, and I'm going to upload that. In a way, you can think about that almost like an install shield or an MSI for hosters, in a way. Kind of, that's the analogy. So I want to browse for the. I'm going to browse for the package that I just created. I'm going to upload. So now a validation occurs. You know, there's no errors in the package, so you are doing things in the right way. There's some warnings that we discovered, like, for example, one, that it says that I'm not referencing the exception handling application block. That was one of the rules. So you might have or you might not have exception handling, but if you're not using that block, I cannot give you anything in addition, you know, as an additional service. And I have your assets. I have the intent of your assets. Now tell me how you want to run this application. And here is where I defined the runtime parameters of this app in Northwind. So I can say, well, if you want, say, single sign-on with federated identity, that's a gold package that you have to buy. And that's something that you have to pay extra for. So let me just select that. And when I do that, there's additional value-added services that the hoster can charge for. You know, on-demand tenant backup, different tenant isolation levels, and let me just one of those. And again, we're not doing any pricing here, but you can imagine in a real scenario how a hoster can price things differently based and given, obviously, the ISV, the flexibility of choosing which services to subscribe to. So I can do this in a shared environment, but with a dedicated server for a database, in a virtualized environment, in a completely isolated. I want my server, my database, my application server. So let's say I do virtualized. So I know I have your assets, I know your intent. You told me how to run it. Now I'm going to acquire those resources in the data center. And you can imagine that Northwind will have some kind of inventory and resource management. And we say, that server over there, it's underutilized, so we can deploy there. That server here, the database is full, so we will provision a new app for a new server for that, and so on and so forth. So you're acquiring resources, we're deploying the app, we'll configure the app. Thank you very much. So let's go to my portfolio. So now you see, Leadware HR, it's on staging. So Northwind gives me a staging environment where I can play with the app. If I want to, I can go here and say, you know, I can have my Q&A team in Leadware testing that my app is working, that all of the functional pieces of Leadware is working fine. So actually, there it is. You know, it's over there. And I can do things like promote the app to production, or I can see value-added services. And the one example that I normally use is this performance and scalability management. Imagine I am a small ISV. I don't have much money. But I think that Leadware HR will be a complete success. And the first market I'm going to is China. You know, millions of users there. How do I know if Leadware will scale for that? How many servers will I need? What should I do? Now, I can go and buy a lot of servers and do a performance and scalability test. Or in this magical world of Northwind, I can go here, click on performance and capacity management and say, hey, can I rent 1,000 servers for a test of 1 week? Do my performance and scalability test, come with some measurements and say, oh, maybe the submit resume should be completely asynchronous. So imagine that kind of use case. I would definitely pay Northwind for 1 week of 1,000 servers to do that kind of testing. And Northwind can do that cost efficiently because those 1,000 servers can be resold the following week to another ISV. See, it's shared among a large number of ISVs. And those not necessarily have to be like automated services. Could be consulting services. So another example I use is a security assessment. I, as an ISV, I'm not an expert on everything. I'm expert on a few things. I'm actually an expert on hiring and recruitment. So what if I could buy from Northwind a security assessment on my app? You know, Northwind could buy the specialized services of an ethical hacking company that will look at my app and say, no, you're doing, you know, we can do SQL injection on your app. We could do whatever. So why can Northwind can do that more efficiently? Well, because they have a lot of apps from multiple ISVs. So they can wholesale the consulting services and resell them in a convenient way. But also because I'm following a model which is predefined. It's always web client, smart client, web services, database. There's a lot of predefined knowledge that I don't need to go and ask you how your application is managed and built. So imagine all the questions. Are you using Ajax? Yes, no. Are you storing, where do you store your configuration? In a registry, bad thing. You know, those kind of questions do not need to be asked because the model is predefined in advance. That's the beauty of this. Okay, so promote to production. We do the same thing. We acquire resources. We configure the servers. We deploy the machines. And then it's in production. And that's another area where Northwind can also sell a number of services. Imagine the second link over there, which it's a killer feature in my book. You know, this clone to staging. How many times an application fails in production, but it doesn't fail in Q&A or staging? Simply because the data in production is different. Well, imagine a magic link where I can take a snapshot of my production environment into staging and automatically generating that so I can test the app with real-world data. That's another feature I'm sure a lot of ISVs would be willing to pay or to partner with a hoster that provides these kind of things. And then there's, you know, the traditional things like, final thing is the management of an app. As an ISV, I would like to see, you know, who's using it, who is, where are the failures, who is my top customer, you know, while I was talking, my application was sold to Global Bank, to Contoso, to the usual suspects, you know, Fabricam. And then I can see, you know, I can do product management of the app. I can instrument the app in such a way that I can know where the problems are and where I should invest my efforts to make it better. And Northwind can do this, like, for example, allow me to configure the SLAs because the model of the app is pre-known in advance. Because my app is made up of web services as a middle tier, each operation in a web service can be instrumented. As an ISV, I can go and say, for me, submit resume is a really important operation, and I want it to be less than 1.5 seconds. If it takes more than 1.5 seconds, let me know. Northwind can instrument that operation non-intrusively because they can place an interceptor before the operation is called. And they can measure before and after and record each and log time entries and time SLAs without requiring me to change the app. So, bottom line, the power of knowing the application model in advance allows the hoster to give a very wide variety of value-added services with almost zero changes in the core of the app, on how the app is built, simply because it's following those conventions and following those architecture definitions. Okay? So anyway, there's a full demo that I recorded and it's posted in my blog. So if you want to see a little bit more of this, right now we are running out of time. But the core things I've shown, so I'm happy. The full story is documented in one of the white papers that we published. So let me go back to my session here. And actually there. So that's pointers and links to some of the white papers that we published. There's one white paper that I'm sure you will remember. It's called ISVs are from Mars and hosters are from Venus, trying to highlight this different mindset from one or the other. That's kind of the theory behind what we showed in Northwind hosting. There's another demo that I didn't have the time to show, which is the consumption, but it's a very short demo, it didn't lose much. With that, thank you very much.